Yeah, so to solve this problem, I'm going to use mathematical induction. So at first, let's see why this sequence is increasing. Increasing means the next term is always greater than the preceding term. So the first term is 1, a1 is 1. So if we want to find the second term using this recursive formula, a2 is 3 minus 1 over a1. And because a1 is 1, that means a2 is 2. 3 minus 1 is 2. So a2 is greater than a1. And let's assume that the kth term is less than the k plus 1 term. Let's say this way. The kth term is greater than k minus 1 term. We are assuming this. Uh, that means, and then the k plus first term. If we use this formula, and because we assume this, if we make the reciprocal, because uh, the sequence is always positive, it's increased because it's increasing. Making the reciprocal changes the direction of inequality. But if we put the negative sign, again the direction changes. So that means this, and this one is equal to the kth term. We are using this formula. If n is k minus 1, this one is this. So this means this one. Look at this. I mean, the now we can see that the k plus the first term is greater than the kth term. So now we prove the sequence is increasing by mathematical induction. So to prove something using mathematical induction, we show the first one makes true, and then assume this. And then if we show the k plus 1 is also the case, now it makes sense in all positive integers. So we just show the sequence is always increasing. And then the second one, the sequence is uh, always less than 3. I'm going to once again use the mathematical induction to show why that's the case, why it's always less than 3. So to do that, at first, the first term is less than 3, and the second thing to show is assume the kth term is less than 3. And then if we look at k plus 1 term, if we use this formula, from this, if we make the reciprocal, the direction changes, but by putting negative sign, once again the direction goes back to the original direction of inequality. So that means this one, if we subtract 1 over ak from 3, that's less than the difference between 3 and 1 over 3. So once again, because 3 minus 1 over 3 is less than 3, we just show that the ak plus 1 term is also less than 3. So in such case, it always the case the sequence is less than 3. So now we know the sequence is increasing and it's less than 3. This means the sequence is bounded above, and because it's increasing and it starts from 1, actually the sequence is always between 1 and 3. In this, so we say this sequence is bounded if it has both it has both the bounded above and bounded below. And when it's always increasing, we say that sequence is monotonous. So when the sequence is monotonous and bounded, the sequence is convergent. When the sequence is convergent, the limit value of the sequence exists. That means if we make this limit value n goes to infinity, there will be a limit value. Let's say the value is L, and in this case, the limit value of a n plus 1 is the same as limit value of a n. When n goes to infinity, it doesn't matter if we take the nth term or n plus first term. So if we make the limit value using this recursive formula, we get this. When you take the limit value to both sides, and we can change this limit value both to L. So that means L is equal to 3 minus 1 over L. So if we multiply L to both sides, we have this quadratic equation. So when we solve this equation using quadratic formula, we have this value, but because the sequence is bounded between 1 and 3, we should choose the plus square root of 5, not minus. Because when square root of 5 become negative, that should less than 1, so that doesn't make sense in this case. So on the limit value of this sequence is 3 plus square root of 5 divided by 2.